Okay, yesterday we discussed about maximum principal stress theory and maximum shear stress theory. The next theory of failure that we are going to discuss today is maximum distortion energy theory. This is known by different names. It is also called as maximum shear strain theory, shear strain energy theory, sorry, Mrs. Hankey theory, or it is also called as von Mises theory, right? So these are different names. In one of the examination question he had asked, find the factor of safety based on maximum shear strain theory, shear strain energy theory. So it is actually distortion energy theory only. So according to this theory of failure, the failure of a material occurs when the total shear strain energy per unit volume in the stress material reaches a value equal to shear strain energy per unit volume at the elastic limit in simple tension test, right? So here the failure criteria is shear strain per unit volume, total shear strain in the material per unit volume. Okay. So the total shear strain energy per unit volume due to principal stresses is given by 1 by 12c sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square. So here we are considering three-dimensional stresses. Later on we will reduce it to two-dimensional. And SYT is the stress at yield point in simple tension, that is tensile test. So the total shear strain energy per unit volume at the yield point, right, is 1 by 12c. Now in simple tension there is only stress in one direction, so it will be SYT, that is I'm taking it in place of 1, and sigma 2 and sigma 3 will be 0. So I'm just putting 0 in all these places. So when you simplify, you get 2 times SYT whole square by 12c. Now for failure criteria is that the total shear strain energy is greater than or equal to the total shear strain energy per unit volume at yield point. So I'm just putting those things in an equation. Now this 1 by 12c on both the sides gets cancelled. So sigma 1 minus sigma 2 whole square, 2 minus 3 whole square, 3 minus 1 whole square is greater than or equal to 2 times SYT square. And if the permissible tensile stress in the material is sigma T, which is SYT by FOS, then we'll replace this SYT with sigma T, right? So then this equation becomes this. Now for two-dimensional stress, sigma 3 will be 0. So just put sigma 3 as 0 here. So we get sigma 1 minus sigma 2 whole square plus sigma 2 minus 0 whole square, 0 minus sigma 1 whole square is greater than or equal to 2 times sigma t square. Now when you expand this bracket and then simplify, you get this expression. So 2 gets cancelled on both the sides. So according to maximum distortion energy theory, sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 should be greater than or equal to sigma t square. Actually that 2 is to be removed there. You will not have 2. So it is, this is equal to sigma t square. We have to use this. Okay, so this is distortion energy theory. Next we will see the maximum principal strain theory. Now according to this theory, failure will occur in a material when maximum principal strain reaches strain due to yield yield stress in simple tension at the elastic point. Okay. Now consider a three-dimensional stress system. This we have discussed already. Sigma 1, sigma 2, sigma 3 are principal stresses in three mutually perpendicular directions, such that sigma 1 and sigma 2 are tensile, and sigma 1 is greater than sigma 2, and sigma 3 is compressive, and SYT be the tensile stress at elastic limit, and SYC is the compressive stress at elastic limit. Now the principal strain in the direction of principal stress sigma 1 is given by E1 is equal to sigma 1 by E minus mu sigma 2 by E minus mu sigma 3 by E. So I'm just taking the common terms. So it becomes 1 by E sigma 1 minus mu sigma 2 plus sigma 3. And in the direction sigma 3, that is the compressive, right? So we have E3 as sigma 3 by E, similar to this, right? You get this. Now strain due to yield stress in simple tension is SYT by E, because there is only one dimension, so directly it is SYT by E. Now strain due to yield stress in compression is SYC by E. Now according to this theory, failure will occur if strain due to principal stress sigma 1, that is E1, is greater than or equal to SYT by E, or modulus of E3. E3, because this is compression, so you can get negative strain also. That is why we are taking only the magnitude of this. So modulus of E3 is greater than or equal to SYC by E. Now just put the values in that and simplify. You get the equation like this. Now this SYT and SYC I am replacing by sigma T and sigma C, which are the permissible stresses. Then the equation become sigma 1 minus mu sigma 2 plus sigma 3 is equal to sigma T, and the second equation become the modulus or the magnitude of sigma 3 minus mu tan sigma 1 plus sigma 2 is equal to sigma C. If any of these condition is true, then there will be failure in the material according to maximum principal strain theory. And the last theory of failure that we are going to discuss is maximum strain energy theory. Now what does this say? The failure of the material occurs when total strain energy per unit volume in the material reaches the strain energy per unit volume of the material at elastic limit in simple tension, right? Now the strain energy is given by half into load into deflection. Now load is P and deflection is delta L, so U is half P delta L. Now P is stress into area, so I have just replaced that, and strain is delta L by L, so delta L can be written as strain E into L, so I get half into sigma into EAL. Now sigma is stress, E is strain, AL area into length of the component is nothing but the volume. So this strain energy is actually half into stress into strain into volume of the material. So here what I am saying is failure of the material occurs when total strain energy per unit volume. So strain energy per unit volume U is equal to this divided by volume. So it becomes per unit volume. So it is half into stress into strain. Now The strain corresponding to three principal stresses are E1 is 1 by E, sigma 1 mu, sigma 2 plus sigma 3. We discussed this in the previous section also. So the same thing is being applied for the three principal stresses. So for three principal stress, I have three principal strains here. Now the total strain energy per unit volume is, I just have to add these three things together, right? So half sigma 1 E1 plus half sigma 2 E2 plus half sigma 3 E3. I just substitute these in E1, E2, E3, and then if you simplify, you get U is equal to 1 by 2E sigma 1 square plus sigma 2 square plus sigma 3 square minus 2 mu sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 3 sigma 1. Now the strain energy per unit volume corresponding to stress at elastic limit in simple tension is we have that formula half into stress into strain. So stress here is SYT and strain is SYT by E, right? Stress by Young's modulus is equal to strain. So this becomes 1 by 2E SYT whole square. Now we are just equating them. So for failure of material, we need this total strain energy per unit volume is greater than or equal to strain energy per unit volume at the yield point, right? In simple tension. Now 1 by 2E is removed. So this is the final expression. Now for a two-dimensional system, sigma 3 will become 0. So this will become 0. Then this equation will become sigma 1 square plus sigma 2 square minus 2 mu sigma 1 sigma 2, and that should be greater than or equal to SYT square. And if sigma t is the permissible tensile stress, which is SYT by factor of safety, then this equation will become sigma 1 square plus sigma 2 square minus 2 mu sigma 1 sigma 2, and that should be actually equal to sigma t square, right? So this will be your design criteria. So I have just put all the theories of failure in one slide, so we can use this for our reference while we are solving the numericals.